Hello students, today we are going to study maths and our topic is fractions. Last time we have seen the types of fractions as well as conversion of improper fraction into mixed fraction. Now today we will start with equivalent fractions. See, for finding out the given fraction is equivalent or not, first by observation we cannot tell. So now with the example, we are going to study how we can find out these equivalent fractions, whether they are equivalent or they are not equivalent. So there are some fractions which I am going to write here. Suppose it is 10 upon 20, 6 upon 12, 8 upon 16, 4 upon 8. Now, in these fractions, if you observe, the numerators are different as well as the denominators are also different. But still, these are equivalent. But then how we can find out these given fractions are equivalent? For that, we have to either multiply or divide by a number these numerator as well as denominator. So here, first we will check with this first fraction. Suppose now, if I write this 10 upon 20 and I divide this with 10. You will find out 1 upon 2. Similarly, if you take 6 upon 12 and divide by 6, again you will find the fraction 1 upon 2. Again now we have the third one, that is 8 upon 16, and we will divide both the numerator as well as denominator by 8. You will get fraction 1 upon 2. Again now the last one is 4 upon 8. If you divide by 4, both the numerator as well as denominator, you will find out 1 upon 2 as a fraction. Now here, even though on observing, numerators you see different, denominators you see different for given fractions, still they are equivalent. How we can say these all the fractions are equivalent? Because when we divide the given fraction with here some figure, that is here first fraction we have divided by 10, the second fraction we have divided by 6, and third fraction by 8, here we have divided by 4. Then we are getting 1 upon 2 as a fraction. And as we see these fractions on reducing, we get the same fraction. We can say these all are equivalent fractions. Is it clear? Yes. So after finding this, all the fractions are equivalent. But sometimes it happens that the given fraction is not equivalent. But then how to find that? So here we have one method, and that is what? The cross multiplication method. We are going to see that. Before that, one more example we will have for this equivalent fraction, and will be confirmed that the given fractions are equivalent fractions. So now I will write the second example, that is here. Now suppose 3 upon 10. This by suppose 50 is given to you. Here, these two fractions, if you observe, you will see the numerators are different as well as the denominators are different. Even now you try this first fraction and divide it with 3, you cannot completely divide the denominator. The same is here. If you divide the whole fraction by 6, numerator as well as the denominator, then you will see you cannot divide this 16 completely by 6. So these you cannot say they are equivalent, but by observing also, if you see, you have to check out. Now suppose this 3 by 10, what will be the equivalent fraction for this 3 by 10? If it is there as question like this, you have to see how can we find the equivalent fraction. Now to find out the equivalent fraction for the given fraction, we have this one method that either you will multiply or you will divide the given fraction by any one number or the figure, so that you can write the equivalent for fraction for the given fraction. So now here, suppose you are having this fraction 3 upon 10, that we will suppose multiply both the numerator and the denominator by 2. Then we will have the answer, that is next fraction is 6 upon 20. That is equal to, again if you take this 3 upon 10 and multiply both the numerator as well as the denominator by 3, you will find out the fraction 9 upon 30. But these fractions after multiplying by 2 or after multiplying by 3, you are getting those are equivalent fractions. Those are equivalent fractions. And how to confirm now? See, again if you take 6 upon 20, you can say these are the equivalent fractions. There is one method. Now here, suppose 3 upon 10 by multiplication method, you have got 6 upon 20, and here by multiplying this fraction 3 upon 10 multiplying by 3, you are having this answer as a 9 upon 30. Now these two fractions are equivalent fractions. How? By again you can confirm by cross multiplication method. So to confirm the fractions are whether equivalent or not, you can have the method that is cross multiplication method. Now we will see that cross multiplication method, and for that we have to consider two fractions as a upon b and c upon b. Then a multiplied by b must be equal to b multiplied by c, and if this left hand side is equal to right hand side, you can say the given fractions are equivalent. Now for this we will have an example that 4 upon 25. We'll have this example and confirm whether given fraction is equivalent or not. See, we have two different fractions, 4 upon 25 and the other is 8 upon 20. Now by using this cross multiplication method, we will have now this a and this will be b. So now a into d. So this is b. This is a, b, c and d. So a into d means 4 into 20. You can get now b here B into C. Oh, yes. Here, now you can say, now this is 4 into 20 is 80. Now 25 into 8 is only 200. So, as they are not equal, you can say the given fractions are not equivalent. But instead of this, suppose we have another example and see how they can be equivalent fractions. Now we have another example, that is 4 upon 25, and the another fraction will be 8 upon 50. Now again, here this 4 will be A, this will be B, here C and here B. And by this rule, as we will find out, A into B is equal to B into C. Means 4 into 50 gives you 25 into 8. So, on multiplying this 4 by this 50, you will have the left hand side answer 200. And to the right hand side, this if you multiply 25 by 8, again you will have the same answer as a 200. Now, in such a cases, when the left hand side and right hand side both are equal, then you can say the given fractions are equivalent. The given fractions are equivalent. When we find this by cross multiplication method, left hand side answer and the right hand side, both answers are equal. Now one more example, if you take, you will come to know how exactly it is. Now suppose you will have another example as a 6 upon 3 upon 6 and the other is 8 upon 12. Any two fractions are given to you suppose. Now in this case, again A into D is equal to B into C. So this is what, according to this cross multiplication method, we are going to see how it can be, whether it is equivalent or not. So here this A into B means 3 into 12 is equal to 6 into 8. So here you will get 36 and 48 is the answer, which are not equal. So here you can say the given fraction, that is 3 upon 6 and 8 upon 12 are not equivalent. So in this way you can say whether the given fraction is equivalent or not equivalent. Now we will have the next point, that is how to simplify the given fraction, or the question may comes that whatever fraction is given to you, you have to reduce it into simplest form. Now suppose you will have one fraction, that is 8 upon 24. Now the question is what? Reduce the given fraction 8 upon 24. Now when such a fraction is given to you and you are asked to reduce. Now previously here we have seen by cross multiplication method the fraction is equivalent or it is not. Now the question is here to reduce the given fraction. Now here the numerator is 8 and the denominator is 24. When such a fraction is given to you, first you have to take the HCF. So with 2 we will factorize the given numbers. So here 2 4s are 8 and 2 12s 6. So here 2 into 2 into 2. You will have the HCF is equal to 8. So when the question is asked to reduce the given fraction into its simplest form, then first we have to find out its HCF. And this now 8 upon 24 you have to divide by 8. That HCF we have found out. Then on dividing the given fraction by this 8, you will find out 1 upon 3. And now 1 upon 3 will be the simplest form of the given fraction. Similarly, if you see one more example, you will find out same way we have to reduce. Now, given fraction, suppose 15 upon 25 has to reduce into its simpler form. Now again, this 15 and 25. This is numerator and this is denominator. And for these both, we have to find out now by factorization its HCF. So as at the end 5 is present, you then start factorization with 5. So 5 3s are 50 and 5 5s are 20. So here after this step you cannot continue the division, as here 3 and here 5 different now factors are there. So HCF will be here only 5. Now after finding this HCF 5, you will divide the given fraction by this 5. So now 15 upon 25 you will divide by 5. Now what we will get here, we will get 5 3s are 50 and 5 5s are 25. So 3 upon 5 will be the smallest or the simplest form of 15 upon 25. So 3 upon 5 is called the reduced form of the given fraction. Now the fraction which we have found here, 3 upon 25, is it equivalent to this fraction? Or in this now example, what we have got 1 upon 3, is it equivalent to the given one 8 upon 24? So that we have to confirm. So for that we have verification method. Again the same method we are using when A upon B and C upon D are the fractions. We are going by cross multiplication method find out the product. So the product here again we will take two fractions. First will be 50 upon 25 and the other will be 3 upon 5. Because we are going to confirm whether the given fractions are now equivalent or not. Even in the sense we have found it the simplest form of this 50 upon 25. So here by the same method we will do. Now this 15 will be A, here B, C and D. Now when you take A into D means 15 into 5 gives you 25 into 3. So 15 5s are 75 and 25 3s are, you will find out by multiplication 75. It means what? Here right hand side and left hand side both are equal, and you can say these are the equivalent. And here by finding these two we can say the reduced form form is the correct and these two fractions are equivalent fractions. So previously in previous example by multiplication method we have found, here by division method we have found the equivalent fraction, and whether they are equivalent or not we have confirmed by this cross multiplication method. Similarly, this reduced form, that is 1 upon 3, and this given fraction 8 upon 23. Similarly, A into B is equal to C into B into C. We can confirm. So here, now suppose 8 upon 24 is given, the another is 1 upon 3. Whether we have reduced and found this answer 1 by 3 is correct or it is incorrect. So for that, again this cross multiplication method we have to follow, and by this method again we will confirm the given answer we have found is correct or wrong. So now after writing this we will do this cross multiplication. So A into B is equal to B into C, means again 8 into 3 is equal to 24 into 1, and we will find out 8 3s are 24 and 24 1s are 24. It means the given fractions are equivalent, and the form, that reduced form which we have found here as a 1 upon 3 is correct. The reduced form of this 8 upon 24 is 1 upon 3 is the correct answer. So this was about the cross multiplication method which we have used to get the equivalent fraction as well as reduced form of the given fraction. Now the next point will be comparison of fractions. Suppose there we have some example like 5 upon 8, 3 upon 8, 1 upon 8. Now these are three different fractions. Many will be there. But in such cases, you can by observation also find out all these fractions are having equal denominator. When the denominators are equal, you can say these are the fractions where for comparison you can find out this out of 8, 5 will be the greater one and 1 upon 8 will be the smaller one. How? See, if you take 8 parts, always greater than if you take a single one. So here you can say whenever you want to compare or when you are comparing any fraction, you have to see whenever the denominators are same, then the numerator which is greater will have the more value and the numerator which is smaller will have the smaller value. So again now there we have to see another example. Suppose there we have another example. Such a case is there. These are the unit fractions where denominators are different but the numerators are same, and everywhere 1 is there. Now, by observing also, whenever you will think this 6, so out of 6 parts, suppose this is 1, 2, 3, 4, 5, 6. Okay, so out of 6, when you take 1, then out of 6, you will take 1 will be always less. When you take out of 3, this one. Yes, so here you can compare the given fractions by observing. And whenever such a unit fractions are given, the denominators are different, but the numerator is only 1 everywhere. You can easily find out whenever the denominator is greater, the value will be less. The denominator is here 3. And the numerator is 1. So, whenever denominator is smaller as compared to these, when you compare these two, you will see the value of 1 upon 3 will be greater. Now, the last one, here we will have one more example where the numerator as well as the denominators are different. Suppose 1 upon 5 and 2 by 3 is given to you. In this case, by observing, you cannot find out they are equal or which one is smaller or bigger. But at such a case, you have to now compare these by taking the LCM. So when you find out the LCM of 5 and 3, you will find out 15 will be the LCM, and you have to multiply and make the denominator equal. So 5 3s are 15, and here again 5 3s are 15, you can write 3 1s are 3, 5 2s are 10. Then both the fractions will have equal denominators, and here out of 15 you can easily find out this 10 is the greater one. I hope children you must have understood by this way which fraction will be the greater, which will be the smaller. So easily you can compare. So next time we will see about the